Alright, here we go on 4.2, number 6. For the data set shown right here, oops, we want to draw a scatter diagram, and they give us information about x and y, and we want to determine the least squares regression line, and then we want to draw it on the scatter plot. So let's go ahead and draw our scatter plot. So we've got x and y. Oops. We want to make sure we put the right scale on here. So we've got 2, 4, well, from 2 up to 9. So we'll go 2, 4, 6, 8, 10. And then for the y, let's do it like this: 1/2, 1, 1.5, 2, 2.5, and 3. That ought to work. So 2 to 1.4, or 2 comma 1.4, 4, 1.8, 8, 2.1, 8, 2.3, and 9, 2.6. Comment on the type of relation that appears to be between x and y. It looks linear. I'm going to go ahead and, it looks like it's, positive, linear, heading upwards, like that. And we've got our data here, and we want to write the equation of the regression line. So we've got our formula for the regression line. Y hat equals b1x plus b0, and we know that b1 is r times s sub y, standard deviation of y, over standard deviation of x, and b0 is y bar minus b1 x bar. Okay, so then let's just substitute our numbers in. So we've got r is 0.957241, and we don't want to round until the very end. S sub y is 0.461519. S sub x 3.03315. So if we plug that in, I'm going to go ahead and do that so you can see it on the calculator here. And I'm going to go ahead and, this is a fraction over 1, so I'm going to multiply the tops together, then divide by the bottom. So I've got 0.957241 times 0.461519 divided by 3.03315 equals 0.145652. 0.145652. 1798. Okay, so there is our B1. That's going to be our slope. And then I'm going to plug that in here for B0. So B0 then will be y bar, which is 2.04, minus this guy, 0.1456 times x bar. And then x bar is 6.2. So watch what I'm going to do on my calculator here. I'm going to put 2.04 minus, and I want this whole answer here, 0.1456. I don't want to round it off, so I'm going to go second answer. So that puts that number in, times 6.2. That way I get the full answer, and I can round it at the very end. 1.14. Now I round it. if I want to round it to 2 decimals or 3 decimals or however many I want to round it to. Since my original data is, up here in the table, looks like 2, it's 1 decimal place, but 2 numbers, I'll round to 2 decimal places. So my final answer then would be y hat equals b0.14 x plus 1.14. Looks about good right there. So there's my regression line, and it says graph it on the scatter plot. And we know my regression line is going to run right through the middle of the data. So for a sketch, if I just draw it right through the middle, that is perfectly okay to do. Okay, if I want to be more accurate, I'm going to put it on my calculator and do all of that. So there we go on that. 13. Oh, bad picture. Sorry about that. Let's read this here. Student at Joliet Junior College conducted a survey of 20 randomly selected full-time students to determine the relation between the number of students, number of hours of video game playing, and grade point average. So we've got hours of video game playing versus GPA. She found a linear relation exists between the two variables, and the least squares regression line is this: negative 0.0526x plus 2.9342. So it goes down like this, whatever the data might look like. So we want to predict the grade point average of a student who plays video games 8 hours per week. So we're going to plug that in for x, 2.9342, and see what we come up with. And so if I do that, I'm going to plug it in on my calculator on the side. So I get negative 0.0526 times 8 plus 2.9342, and I come up with 2.5134. That would be the predicted GPA. Okay, so if this is 8, wherever 8 might be, then according to my regression line, the GPA would be 2.9 or 2.5, sorry about that, 3134. That's what my regression line predicts. Interpret the slope. The slope is this guy right here. The slope is negative 0.0526 over 1. Now my units are GPA, because that's my slope is y over x over hours. So what that means is for every increase, so on average, for each increase of 1 hour of video game time, there is a decrease, because it's negative, a decrease of 0.0526 in the GPA associated with that. Okay. So you can kind of see that for each in the slope, for each hour that you increase of video games, the GPA goes down by a certain amount, right? So for each you increase it by an hour, it goes down, the GPA goes down by how much? On average, by 0.0526. Okay. C. If appropriate, interpret the y-intercept. Well, the y-intercept right here, that happens when x is 0. So if you don't play any video games, if you're during the week, that's this point right here. That would be the GPA you would expect to have if you don't play any video games. Let's see. If x equals 0, that means no video games per week. I would expect a GPA of 2.9342. And lastly, D, a student who plays video games 7 hours per week has a grade point average of 2.68. Is this student's grade point average above or below the average among all students who play video games? Okay, so what are they saying here? D. A student who plays video games has a GPA of that, so that's an actual value. Is this above or below the GPA among all students who play video games? Well, what are we going to predict? Y hat is 0.0526 times 7 plus 2.9342. So that's going to be let's do it over here on the side. 2.566. So this is what I'm predicting from my data, GPA, and this is what he has. So his GPA is above what we would expect. This is a little misleading because they're saying, is it above all of them who play? Well, it's not. We don't know for sure. We just know that this is what we would expect them to get, right? So there we go. All right.